take a notebook itself, and I think you have all drawn the previous diagram that I have shown, and I would want you to take a notebook also. Okay, is my screen visible? Can everyone see my screen?
Yes, sir.
Okay. So please take your notebooks, and below the diagram that we have drawn before, you have to write. So I'll explain the diagram once again. So we have a vehicle here with the front wheel shown here. These are the front wheels here. This is one front wheel, and this is another front wheel, and these are the rear wheels. Here are the rear wheels, and there is the roll center axis through which the vehicle, once moving or once the centrifugal force acts, it rolls in this axis. Okay, so the vehicle is moving in this direction. Vehicle is moving in this direction, and while taking this curve, a force acts, that is the capital F, acts through the center of gravity. This is the center of gravity, and the center of gravity was initially at this position. Okay, it is present at this position, but it is then being shifted to this direction by means of weight shift that I have explained it before in the previous class. So once the weight is shifted here, the force that acts in this direction is the centrifugal force. So what is the centrifugal force? So if you look here, so two types of forces occur when a body is rotating. So when a body is rotating in a singular axis shown here, the body tends to move once released from this force. Okay, once released from this force, the body is tending to move in this direction. Okay, the force that holds the body in this circular motion is called as the centripetal force. The force that holds the body in this circular motion is known as the centripetal force. So what is centrifugal force? Centrifugal force is nothing but the force through which the body then goes outside. Okay, it tends to move outside, and it goes in a tangential direction, and that force is known as centrifugal force. Okay, centripetal force is the force that is exerted from the center of the circle that holds the body in a rotational motion, while centrifugal force releases the body, or the body tends to move outwards due to the centrifugal force acting. Okay, so the centrifugal force here is the force that is shown here. Okay, that is the equivalent force. So against this force, okay, there will be a front force in that direction, front from the front axle, and also there will be a front the force in the rear axle. So that are the force that are occurring in both the axles, and the resultant force is F shown here, and it acts through the center of gravity. Then the center of gravity is displaced from a height. You can see it is from the roll axis, it is about an distance of A shown here. This is A, and for the roll axis from the ground is at a distance B. Okay, the combined distance, or the distance of the center of gravity from the ground here is H. This is H shown here. Then there are some terms, the SF, which is called the stiffness, which I'll explain it when we are studying stiffness, and the distance, the total distance, that is C plus D. Okay, that is the wheel base. Okay, the wheelbase. So C is the distance of the center of gravity from the front axle, while D is the distance of the center of gravity from the rear axle. Okay, so that is correspondingly C and D, and the total length here from the front axle, from the center of the front axle to the center of the rear axle, is known as wheelbase, and the distance from the center of the rear wheel to the center of from the center of one rear wheel to the center of the other rear wheel is called wheel track, which is denoted by T, or it is also the distance from the center of front wheel to the other center of the front wheel. So that is also track. Okay, and with that we are resolving the triangle that is formed here due to the weight shift that is formed here to a bigger diagram that is shown here. Okay, this is the bigger diagram, and the distance here will be denoted as x. So this is the distance x. Okay, so we are looking for tan theta. So what is tan theta? Okay, tan theta, we know that. Please write this down also. Okay, while I am explaining, please write it also. So what is tan theta? Tan theta is opposite by adjacent angle. So the theta is formed between the weight shift of the center of gravity. So the center of gravity was present here and it is shifted to this area. Okay, it is shifted to this area. And through the center of gravity, the weight acts. So that is what is known as W, that is shown here. The weight is acting, weight always acts downwards due to the gravity. It is acting through the center of gravity, and due to the gravity the weight always acts vertically downwards. Okay, the weight acting is from this point, so there is a shift of weight here. You can see the shift of weight because the weight is then acting at this point. The distance that is formed in between the weight shift is known as x. Okay, we are terming it as x, and tan theta is nothing but opposite by adjacent. So the theta formed here, we are taking the opposite angle, that is x. Okay, that is x by adjacent. This is the adjacent side. Okay, from the theta, the opposite side is x and the adjacent side is a. So x by a is tan theta. Therefore, when we are looking at x, x will be equal to a tan theta. Okay, so this distance, that is x, will be equal to a tan theta, that is shown here. Okay, so the x that we have obtained here will be equal to x tan theta. Okay. Next, write the heading body roll couple. Body roll couple. So what is body roll couple? So before understanding body roll couple, we have to understand what is moment. So moment is nothing but, write this down, moment is equal to force into perpendicular distance. Force into perpendicular distance. Okay, moment is equal to force into perpendicular distance. So here we have two kinds of forces. Okay, one is the resultant force, which is F, and another is the resultant force. Another force is the weight that acts downwards. Okay, the weight that is shown here. Okay, two forces are there. One is resultant force F, another force is the force W that acts downwards through the center of gravity. So we are resolving the forces. So we are taking a force, the force acts in this direction, then its perpendicular distance is then calculated. Okay, so moment will be equal to the force that is provided here, and there will be a distance. Okay, so it will be equal to force into a distance. Okay, here in this case there is a force here and a distance a, so the moment will be equal to force into the perpendicular distance. So the angle that will be formed here will be 90 degree. That is what is known as a perpendicular distance. Okay, so we are looking at the force. First is the F. Okay, if you are looking at F is in the direction of where the body goes. Okay, in a linear motion, the body always moves sideways, or the vehicle moves in the sideways direction. Then it rolls from the roll center. Okay, it rolls through the roll center. So two actions are taking place. One is the linear motion sideways, specifically here in the direction of left, because the vehicle is moving in this direction. So this is the front, this is the rear. So two types of motions are occurring. One is the horizontal motion through F. Okay, due to F, there is a horizontal motion, and also the body rotates while moving. Okay, it rotates while moving in this direction. That is how the car flips over. Okay, so there are two forces, and this translatory sideway motion is occurring due to F. Okay, so we have two forces, and F that is generated is known as the centrifugal force. Okay, it is known as the centrifugal force, and the moment it creates is known as centrifugal moment. So please write it down. Centrifugal moment. Okay, centrifugal moment is equal to F into A. Centrifugal moment is equal to F into A. So where does centrifugal moment occurs? So centrifugal moment occurs in the direction of F, and the moment will be equal to the force into its perpendicular distance. So here the perpendicular distance of the force is through this. We are looking at roll center axis. Okay, so the roll center axis is this line here, and through the roll center axis, the distance of F with the roll center axis is A here. Okay, it is A. So the moment is equal to F into A. So the centrifugal moment is equal to F into A. In the next line, write transverse displacement moment. Transverse displacement moment. So what is transverse displacement moment? So I have told you there are two forces that occurs. One is the sideways force, the other is the roll force, and the roll force is occurring due to the weight. Okay, the weight is present in the downward direction through the center of gravity, and its perpendicular distance forms a moment. Okay, the weight and its perpendicular distance forms a moment. So the perpendicular distance here, so the weight acts at the center of gravity, which is shifted here, and its perpendicular distance with the roll center axis. So the roll center axis is here, and its distance, that is this distance, or it is equal to this distance. So this is the distance. Okay, and that distance we have already found out, which is x, and x is equal to a tan theta. So please write down the transverse displacement moment is equal to W into X. Okay, W into X, and in the next line, please write down, which is equal to W into A tan theta. So in the displacement moment, so due to the displacement moment only, the body rotates, and for that, that moment is equal to W A tan theta. Okay, if you want, you can write this down also, with where F is the centrifugal side force, the resultant centrifugal side force acting through the center of gravity. A is the distance between the center of gravity and the roll center axis. Okay, please mention axis also. Okay, distance between center of gravity and roll center axis. W is the unsprung weight, so the weight that is responsible for rolling of the body. Then comes theta, that is angle of body roll, or the angle formed by the shift of weight. Okay, Next is total roll moment. So please write down this one. So total roll moment is equal to centrifugal moment plus transverse displacement moment. Total moment is equal to centrifugal moment plus transverse displacement moment. Total roll moment is equal to centrifugal moment plus transverse displacement moment. Okay, then write down M. So total roll moment is denoted by capital letter M, which is equal to, we know that centrifugal moment is equal to Fa, that is the Fa shown here, plus transverse displacement moment Wa sin theta. Wa sin theta. And if you want, you can take A commonly outside. A is present here and here also, and you can take it commonly outside, and then you can write the equation M is equal to F plus W tan theta into A. You can write it in such a manner also. Okay, did everyone understand this? Any doubts?
Sir.
No, sir.
Okay. Next, please write down body roll stiffness. Body roll stiffness. Body roll stiffness. So the basic definition is, it is defined as the roll couple produced per degree of body roll. It is defined as the roll couple produced per degree of body roll. So that definition itself is in the equation. So it is the roll couple produced per degree of body roll. Roll couple divided by roll angle. So roll couple is M. So we have already found out roll couple, and roll couple was the moment that we have found out here. Okay, that is also the M shown here, and it is so we can write down S is equal to, roll stiffness is denoted by S, and S is equal to M by theta. M by theta. Please write down the units also. Newton meter by degree. Newton meter is the unit for moment, and degree is the unit for theta. Where S is the roll stiffness, M is the roll couple, and theta is angle of roll. Theta is angle of roll. Okay, so when we look at this diagram itself, I have already told you there is a SF here and an SR here. Okay, and the resultant, this S is denoting the stiffness. Okay, the S is the stiffness. So the resultant stiffness is what we are terming as S. So we have defined the resultant S, and that is roll stiffness, that is equal to M by theta. So it's more specifically this M. Okay, it is not a small m, but this M. You can write it also. It is equal to M, or the roll couple is equal to the total roll moment, not movement. It is moment. Okay, it is mentioned here moment, but it is moment. Okay, so that is what is body roll stiffness. So when you are taking for a rear and front wheels, we had two stiffness, SF and SR. So write down the fractional torsional stiffness, for the front and rear suspension, is given by SF is equal to SF by SF plus SR. SF is equal to SF by SF plus SR, and SR is equal to SR by SR plus SF. So this you can write it SF plus SR itself. There is no problem because it is addition. So SR by SF plus SR also is right. So if you want to study, you can write it in such a way. Okay. When the question for this is asked, it will be basically asked under body roll analysis. Okay. When if there is a question for 10 marks and it is asking for you to write about the stability of body roll analysis, then you have to write various components: body roll couple, body roll stiffness, and etc., which we are going to study. And once you are writing that, you just have to write the formula itself. Okay, you don't have to go for any derivations and all. Small derivations are shown here, so you just have to mug up this derivation. So there will be no problems related to this, but simply they will be asking the analysis, or they can ask specific topics itself. Body roll stiffness they can ask, or they can ask body overturning couple. So specific topics will be mentioned in the question, and you have to write accordingly. You don't have to write any derivations, etc. You just the final equation and what each of the terms are denoting. And if there is a diagram of this shown, it will be much helpful for the examiner or the invigilator to find specific terms that you are mentioning. Okay, so you have to study this diagram. Then, so SF and SR are shown here. So it is written as SF is the fraction of front torsional stiffness. Fraction of front torsional stiffness, and SR is the fraction of rear torsional stiffness. So another question that arises is, what is torsional stiffness? So you can write down what is torsional stiffness. Torsional stiffness is defined as the amount of torque required for twisting an object by unit radian or unit degree. Torsional stiffness, please write down. Torsional stiffness is defined as the amount of torque required for twisting an object by unit radian. Okay, it is defined as the amount of torque required for twisting an object by unit radian. So what is torque actually? Torque is nothing but, if you have force, that is push and pull force, you know what is push and what is pull. So these forces are occurring in the linear direction. These forces are occurring in the linear direction. Hence the term linear force. Okay, while the force that occur in a rotating direction, that is known as torque. Okay, there will be a rotational component of the force, and that is known as torque. And torsional stiffness is defined as the amount of torque required for twisting an object. So actually, a car is a rigid body, so there is no rotation of the car in this roll direction when it is moving. Okay, rotating components are the gears, the propeller shaft, the differential, etc. are the rotating components. But when it is flipping over or rolling in this roll axis, a twisting moment occurs. A twisting moment, the moments we have discussed. So two types of moment were there. One for the linear direction, that is the centrifugal force, and another for the rotational direction, which is due to the weight. Okay, and these two moments are responsible for the movement of the car rotating and moving sideways. Okay, that is what is coming under body roll couple. And stiffness is the resistance against this roll. Okay, it is the resistance. So it is a rigid body. A car is a rigid body. It is not fluidic for moving in a rotational direction. So for that, it provides a stiffness, and that stiffness is mentioned here. Okay, it occurs at the front wheel and also, sorry, at the front axle and also at the rear axle, and that is what is known as torsional stiffness. Then the next one is body overturning couple. So please write down body overturning couple and draw this figure. So this is the same figure that was shown before. It was a 3D diagram, and this is the 2D diagram of the figure. So please draw this figure. Okay, while drawing, you have to notice that there is a considerable difference here. Okay, there is a difference of length here, and you have to draw it accordingly. This is due to the weight shift. Okay, this is the weight shift that is being shown. Okay, has anyone drawn the figure? Can anyone respond? Did you draw the figure?
Yes, sir.
Okay, okay, okay. So, so the next is overturning couple. So we had studied about body roll couple, wherein the moment is occurring. Okay, the moment through the moment the overturning occurs. Okay, there are basically two types of moments. One is the centrifugal moment, another is the displacement moment. So based on that moment, there will be an overturning couple. So this figure shows the front wheels. So how do you know that it's the front wheel? There is a term here, F1 and F2. So if you look at the previous diagram, so if you look at the previous diagram, there is two forces here, that is F1 and F2. So what was F1 and F2? So we know that the vehicle moves in this direction, in the direction of the resultant force F. And when it is moving in that direction, due to Newton's third law, for every reaction there will be for every action there will be an equal and opposite reaction. So there will be a reaction occurring at the wheels in the opposite direction, and this reaction is the resultant for preventing the car to roll over. So if you are taking a curve, okay, when you are taking a curve at a permissible speed limit, so if the speed limit of the curve is 35 kilometers per hour and you are going at 30 kilometers per hour and you are taking the curve, and when you are moving that curve, your car is not flipping over. This is due to the reaction force at each of the wheels. The reaction force F1, F2, F3, and F4. So F1 and F2 are the reaction force at the front wheels, while the F3 and F4 are the reaction forces at rear wheels. So this is the body does not roll due to the reaction forces occurring at each of the wheels. And when we are increasing the speed above the permissible speed limit, that is basically if it is above 35 kilometers per hour. So if you are going or if you are serving the curve at 40 kilometers per hour, the body tends to roll over. So what is happening is that if a force generated, that is the resultant force, will be much greater than the reaction force occurring at each of the wheels. So if the force that is occurring, that is F, or more specifically FF, that is the the force occurring or the centrifugal force occurring at the front axle, and FR is the centrifugal force occurring at the rear axle. If that force is greater than the resultant force or the resultant reaction force, then the body flips over. So that is what is happening for overturning. So in an overturning condition, there will be a weight shift. So the weight shift is shown here. Okay, the reaction force is occurring here and the body is going to flip over to this side. Okay, it is going to linearly move to this direction, and it will be flipping over in this direction. So it will be flipping over in clockwise direction, and the reaction is occurring or the reaction forces are occurring in this direction. Okay, so for that, there will be a weight shift. So that is what is the distance shown here. Okay, there will be a significant distance between the inner and outer wheels with the body. So the body's difference here will be, or more specifically, the outer wheel will be less, while in the inner wheel, it will be much greater. This is due to the weight shift. And due to the weight shift, there will be a overturning moment. So how is the overturning couple stated? It is So an overturning couple is formed by FH. Okay, it is formed by FH, a moment FH, and that is the overturning couple. And due to the weight shift, so initially the weight shift was from a small direction, which was negligible. So we are just for terming the moment, we are writing W as x tan theta. So this is that distance x tan theta. And once the weight completely shifts to this wheel, okay, or to the outer wheel, if it shifts to the outer wheel, more specifically here. So the weight shift occurs till here. Okay, once the weight shift occurs here, the body completely flips over. Okay, it completely flips over. So the both the moments that occurring here are one moment for the translatory or the centrifugal force, and that centrifugal force is FH. Okay, you must understand one thing. This is overturning while this is a roll couple. Okay, roll couple. So we have a distance x here and a distance x here, and this, when this x becomes equal to the distance from here to here, okay, or from here to here, the body flips over. Okay, if it is equal to, when x becomes equal to t, please write down, when x becomes equal to t, the body flips over. When x becomes equal to t, the body flips over. So we were discussing here about roll couple, or the moment that is responsible for the roll of the body. But here we are discussing about the couple that overturns the body. Okay, we are turning the body. So the weight is shifted completely towards the outer wheels. Okay, it is shifted completely to the outer wheels, and when it shifts, the moment that is generated will be equal to W into T. W into T. So the moment will be through this axis, and it will take the complete track. Okay, it will take the complete track, so that this wheels also lifts up. So this wheel lifts up and this goes downwards. This is how the rotation takes place, and then once it rotates, this will go up, and so like that there will be a circular motion. Okay, so write down, the overturning couple or the centrifugal couple that is generated will be equal to F into H. F into H. Centrifugal couple will be equal to F into H. And the displacement moment or the displacement couple, transverse displacement couple, will be equal to basically two types of moments, right? So transverse displacement couple is equal to W into T, will be equal to W into T. W into T. In overturning couple, write down, okay. In overturning couple, centrifugal force will be equal to transverse displacement couple. Centrifugal force will be equal to transverse displacement couple. Transverse displacement couple, which is equal to WT equal to FH. Sorry, write the other way around. FH is equal to WT. FH is equal to WT. So centrifugal force couple will be equal to transverse displacement couple moment. That is FH is equal to WT. Okay, then we are taking taking the T here. So W will be equal to FH by T. So that is the weight that is transferred. weight that is transferred. Okay, then please write down Wt is equal to, so okay, put this in a box, okay, put this in a box. Then please write down this again. Wt is equal to Wt is equal to Fh. Wt is equal to Fh. Okay, then which is equal to Wt is equal to Fh is equal to, write down mu. Write down mu. So what is mu? Mu is the body roll couple. So where, write down, where mu is equal to body roll couple. Mu is equal to body roll couple. And finally write down mu is equal to, don't write down Fh, while write down mu is equal to Fh, mu is equal to Fh, and H is equal to, okay, write down in brackets, H is equal to A plus B. H is equal to A plus B. H is equal to A plus B. So here is it is shown here. H is equal to A plus B. So it is the sum of the distance of roll center axis to the center of gravity and the roll center axis to the ground. So it is the sum of roll center of axis to the center of gravity and roll center of axis to the ground. So that is A plus B, and write down mu is equal to F into A plus B. F into A plus B. And if you are putting F into the bracket, we will get mu is equal to Fa plus Fb in Newton. In Newton. So that is the overturning moment or the overturning couple. So this is responsible. Once mu is equal to Fa plus Fb and W is equal to Fh plus T is satisfied, the body rolls over. Okay, that is how body overturning is done. So any doubts? Did you understand this? Hello, can you hear me?
Yes, sir.
Any doubts?
No, sir.
Okay. So I'll wind up the session today, and next I'll take the attendance.